Okay, we're going to talk a little bit about what we did today. So today we're going to talk a little bit about what's called conditional probability, and we're going to talk about independence, the idea of independence. So what we have here is we have a situation where we have a survey that was done 100 mothers aged 40 to 44 in 1976, 1994, 2014, and they asked them how many children they had. So that's our two-way table here. So just as a review, two-way table, we got categories coming down for the rows, categories going across for the columns. Anything that's marginal is going to be like, so if I were to ask you, what is the probability of having one child? The probability of having one child is 54 out of 300. If I were to ask you, what is the probability of being surveyed in 1994, that's these people here, that's going to be 100 out of 300. And just as another kind of follow on, we'll say, what is the probability of having one child and being surveyed in 1994? That's these 21 out of 300. And the final one, what is the probability of having one child or being surveyed in 1994? And again, our rule on that one is we're going to take all the one child people, so 54. We're going to add all the 1994 people, 100, so 154. But that it double counts these 21, so it's 154 minus 121. Okay, trying how hard I'm doing in my head right now. So 133. 133 out of 300 is what. So it's a little bit of a review of like that one rule we have. It's on the formula sheet, but you need to kind of be familiar with it. So now, conditional. Conditional now we're not talking marginal. We're not talking out of the total. We're not going to be talking out of 300. We're going to be talking out of the column totals or the row totals. So the given is going to tell you whether we're doing a row or a column. So in this case, we know that C has 4 or more children. We know that S is 1976. We know that N is 1994. We know that F is 2014. So those are our events. We've defined them so we don't have to keep calling them by their numbers. So this right here, if I want to read this, what is the probability of C happening? What is the probability of having 4 or more kids, 4 or more children, knowing it's S, and in this case, S is going to be 1976. So this is saying, I know we're in 1976. How many families in 1976 had 4 or more children? So in this case, the probability of C given S, that's how you read it, is going to be 40 out of 100. And if I wanted to interpret that, that is saying that 40 women responded 4+ children when surveyed. Surveyed in 1976. So that's a conditional. And if I had asked it the other way around, if it had said this, probability S given C, this would have said, what is the probability that given you had 4 or more children, that it was 1976? So again, this one is saying, given 4+ kids, what's the probability it being 1976? So again, that's saying these 66 people, so this would be 40 out of 66. That's just another way to read it. Now, reading the next one, given that a mother was not surveyed in 1976. So if you think about this, not surveyed in 76, sorry, it's going to be the 94 and the 2014. So basically we're rolling these two guys together. We're kind of pinching these two together. What's the probability that she has 4 or more children? So again, if you want to write this, the way you would write it is, what is the probability given that it's not 1976? So in this case, we're going to say S with a little c. That's not 76, not 1976. What's the probability of this? And the way we figure that out is we have 100 people in 1994 13 of which had 4+ kids. We have 100 women in 2014. 13 of them had 4+ kids. We add those together, we get 26 out of 100. So that is our probability there, and that's just another way of doing a conditional. The last one says, are the events surveyed in 1976 and 4 or more children independent? Okay, so let me talk about what independence means. Independence means that the condition doesn't matter to the probability. In other words, the probability of me having 4 kids is the same regardless of the year we're talking about. So the way that you need to think about this is, what is the probability that you were surveyed in 1976? The probability that you were surveyed in 1976 was 100 out of 300. Okay. Now we want to look at the probability that you were surveyed in 1996, given that you had 4 children. So in this case, we kind of figured that out up top. This is going to be, you were surveyed in 1970, or given, sorry, I said probability given you have 4 children, you were surveyed in 1976. So now what I'm doing is I'm looking at this row right here, and I'm saying 40 out of 66. And then the question I'm asking, do these 2 proportions equal one another? Do they equal one another? Does 100 out of 300 equal 40 out of 66? And if you take a look at that, you can clearly see this is 1/3, and this is right around 2/3. So this is not true. This is a false statement. So that tells me surveyed in 1976 is not independent of having 4 or more kids. Let me say that another way. If I know the year you were surveyed, it affects the probability of you having 4 or more kids. So take a look up here. If I know what year you were surveyed, notice it was 100 in every case. When I look at this, if I know it, I can tell you for a fact that this is a significantly different number than that 13. 40 is different than the 13. So they are not independent. And the big thing I want to focus on this has nothing to do with mutually exclusive. Remember, mutually exclusive is saying they cannot happen at the same time. And if you look at this table, there's nothing mutually exclusive here. There would have to be a 0 in the table for that. So that's kind of what we talked about today. We did it with the taco tongue and the evil eyebrow thing. So again, use the reflection, ask me questions, and ask and come see me and ask questions. And we're just going to kind of keep going this. We've got a couple more days on this unit, and then we will be ready to move on.